might as well get started. While people trickle in, it won't detract from the larger message. The first thing, which you all have been hearing, is that we would like to record this in order to get additional content. We've scheduled this 12:15, so people have plenty of time to ask the speakers questions, and the speakers can give a full presentation. Just so you know. Today we are really privileged to have two very good speakers. Well, the first speaker is going to be Rich Heineman, who works PennDOT. He was on our advisory committee for our symposium 2 years ago. He knows much more about stormwater than I ever will, and he's going to tell you about that. He's going to be, I think, focusing on how to design for maintenance. As our arc here, from planning to design to funding, design is in the middle. It's fundamentally important. And Jim Pillsbury, who's been working a long time with Westmoreland County Conservation District, a lot of that working very, very specifically on stormwater infrastructure. So he too has a lot of experience. He's going to be talking about how to go back and look at your infrastructure, maybe redesign it a little bit, make sure you're getting all the function you can out of it. If you would like a professional development hour, we're able to offer 1 hour for today. Please just type your name in the chat and we will email or get in touch with you with a certificate after this lunch and learn. If you have questions that you would like to ask, please also enter those in the chat, and that way we can get those. And it's also fine to shout out, but sometimes getting long lines. So by all means, as a question occurs to you, please enter in the chat. And so we'll have brief Q&A after each talk, and then a lot more extended Q&A after both talks are completed. We have one more webinar coming up that should be in late October, early November. And that's when we're going to shift our focus from design to funding. And there we're going to try to have people that can talk about layering of funding. How can you use one program in conjunction with another to enhance your stormwater projects, to get more function out of your stormwater management? Again, we'll have a PDH, but we have to finalize a date. That should be coming out in the next week or two, and we'll send that notice to all of you all. And the final thing, and the culmination of all this activity this year, is December 4th. We're going to be having the second IRISE Stormwater Symposium here on Pitt's campus, and we're gearing up to start registration and all that process. So you should be hearing from us as well about that as soon as, very soon. Now you can stop listening to me, and I am going to pass the screen to Rich Heineman, and we look forward to hearing what you have to say.
All right. Thanks, Dan. All right. Dan, you guys can see my screen, correct? Just want to make sure it's sharing so I don't ramble on.
Oh, yeah, you're good.
I'm good to go. All right. Good morning, everyone. Like Dan said, I'm Rich Heineman from PennDOT. I'm working in our central office here in Harrisburg. I'm the stormwater section chief here. Pretty much anything stormwater I'm kind of involved in. I focus a lot more on the maintenance and construction stormwater compliance, but I work a lot with our design folks to make sure, things are being able to design permitted properly. So I'm just going to kind of get right into my presentation here today. So just kind of an overview of the topics. It's going to seem like I'm talking a lot about maintenance, but I'm going to interject design, things that we see. And then at the end, I still think it's important to kind of talk through that whole design to construction into maintenance and that knowledge transfer, which is pretty important on my end. So to go over that, I'm going to kind of go over our inventory, just give you a feel of how many SCMs we have, how we came up with them. I'm going to focus a lot on stormwater control measures. You'll probably hear me say SCMs about 30 times today. Um, if you're not familiar with that term, a lot of folks still use basins, ponds, BMPs, but I'm really focused on those stormwater control measures here. We did a mini study on SCM inspection results that we use a lot to help change some of our designs. Like I said, I'm going to talk about our maintenance training and all that. So the first thing we started with when I kind of took over the stormwater control measure maintenance program, we have a maintenance manual. Even though it is a maintenance manual, we kind of cover everything in there. We have other manuals, design manuals that tell our designers how to design to meet the permit limits. But even those designers still look at this Pub 888 to kind of see, you know, how things should be maintained, how they're going to be maintained so they can kind of design those SCMs properly. We cover everything from inventorying to our inspections. There's different types of inspections, the maintenance, how to perform maintenance on them. There's common components, how are folks scheduled and charge those when they're going out doing that maintenance work. Our SCM inventory, we really didn't have a centralized one here till 2015. If I needed to know information about an SCM or how things were designed, we run out to our districts. They had like paper files in a tin shed somewhere. Um, so it was kind of hard for us to kind of get a good understanding of what was going on out in the field. So we took a major effort here in central office. We actually went through 500 different projects, extracted all that information from the plans, and started creating our inventory. Um, so it took us a little bit to get there, but right now I say our inventory is pretty accurate and rock solid, and we have lots of information in there, which helps us in the long run. In that inventory, it's basically all of our department-owned SCMs. We do sometimes add non-department-owned SCMs if they're right along the roadway, and we get lots of questions like who owns that. Sometimes we'll add them in, but it's just the ones that PennDOT owns and operates and maintains. We have like 40 plus data fields. We pretty much anything, any data that's associated with that SCM, we capture that data and keep it in our files in case anyone asks us a question down the road, like how it was designed, what's the drainage area to that, anything that's kind of in that permitting design side. We in maintenance kind of take that and keep that for the life of that SCM. We in central office review all new stormwater control measures and all that data. So districts will send us that information, and there's about four of us here that review all that data to make sure it's accurate, it makes sense, it's the right type of SCM. We store all those documents associated with those SCMs, all the as-builts, the plans, the permitting, kind of everything in one-stop shop for anyone that needs to know information about that. So I like to kind of point out here, PennDOT, I always like to tell people we're probably the number one, we have the most amount of SCMs in Pennsylvania. Right now, we're up to 4,500 SCMs that PennDOT's responsible for across the state. So we have a lot to do and a lot to maintain, which is good. We get a lot of data from that, seeing what issues we're seeing after construction, things we have to tweak and design, long-term O&M issues that we see. So we have a pretty big sample size, which helps me kind of look at that, but it's a lot of work for our crews and districts to kind of maintain them. Right now, I like to kind of talk about our SCM inventory growth. We're adding anywhere from about 300 to 400 SCMs a year. So you can see here on this graph, and it is growing exponentially. Basically, if you look at 2010 on, when DEP started having those regs that we had to build them, but we're not getting any less SCMs, right? So it's important for us to look at that, how we're maintaining them, how they're operating. I will tell you our SCM growth is tied to our department's program, meaning if we get a lot of money and we're building a lot of new roadways, we get a lot more stormwater control measures added to that inventory. And like I said, these first couple slides, I'm just trying to give everyone a background where we're at in PennDOT, but our centralized database, we store all that information in what we call our maintenance IQ. It's a custom GIS application for PennDOT, which houses all that. Anyone in PennDOT can see that information. They have to just click on that dot. It gives you anything you need to know about that. It has inventory data, inspection data, all of that information. So to get all that information, we have two different type of inspections that we do here at PennDOT. So on a 3-year cycle, we do visual site inspections. To do those inspections, we require folks to take a 1.5-day training. It's required to do those. It's a lot of information, but I always tell folks the VSI, you really don't even need a plan to go out and do that to inspect those. We're looking to make sure it's still functioning. Like we don't have a lot of erosion, too much vegetation, structural issues. It's just that high level inspection that we do once every 3 years. The other inspection we do is a condition assessment. We do that 1 year after construction. The reason is we feel that an SCM 1 year after construction is pretty much settled in. We're not going to see a lot more issues. And then every 10 years after that, typically that's an engineer or environmental professional doing that analysis. It's a very detailed, it's like 2 to 4 hours on site, depending on the size. They're confirming that, it's still built per the as-built plan. It's still functioning properly. That also requires a 1.5-day training, so those folks have to go through that to do those inspections. So kind of getting to now, what Dan said I was going to talk about, to kind of understand what we need to look at in design and change some of those designs. We took a lot of that inspection data, seeing some of those issues we have. So we have SCMs that have been out there 10 to 15 years. We have ones that have been out there 2 years. So we kind of looked at over 5,600 different types of visual site inspections. So we're looking at the most common problems that we see on these. We kind of group these problem categories into debris, trash, erosion, ponding, vegetation, some miscellaneous stuff. If you can see here, and debris and trash was kind of our number one problem. We see a lot of debris and trash in our SCM floors, side slopes. The second area we see that a lot in the inflow channels. So to kind of tie that into design, when we talk to folks about when we're doing design, whether it's a forebay or some way to start, I don't want to say capturing the trash and debris, but limiting the area of that trash and debris that goes throughout the SCM. So when our crews go out there and have to pick up that trash, they're not having to go through this large SCM and spread out evenly. So some of those, forebay designs kind of come into play. I have some slides and examples later on. Erosion, we see a lot of. So that SCM bottom and side slopes, we see a lot of side slopes where we'll see erosion on those. So making sure when we're kind of looking at that design, not having those side slopes so steep, trying to tuck them in there, or making sure we have the right vegetation, or if we have to, does it have to be rocked or rip-wrapped or stuff like that? So we don't see that accelerated erosion. So trying to focus on that in the designs. So then our crews later on don't have to go back and fix that 2 to 3 years after it's been up and running. We see a lot of standing water issues, ponding when it's not supposed to be ponding. We have a lot of infiltration, not a lot, a good many infiltration basins that aren't infiltrating. So, stressing that importance in design, making sure we're doing enough of those tests early on in design to make sure it can infiltrate, and then making sure we're looking at that long-term performance of those infiltration basins. Did it infiltrate year 1, but now we're at year 10 and it's not infiltrating, and then what's causing that? I don't have all the answers to that, but we're trying to look at that, making sure that we're if it's just barely infiltrating into design parameters when you're looking at it, it's probably not going to get any better 2 to 3 years later on. So So those are kind of the big ones that we kind of took these inspection results and looked at that overall. Just kind of looking at the different types of SCMs. So I just kind of lump basins all together. We see every type of problem category across, but the most engineering evaluations that we had to do is that standing water and dry basins. So we have to go back and look. It was like 240 some basins that aren't supposed to have standing water, but they do now. So that's probably going to change here. So some of the things we're looking at, and some of this is a regulatory driver, is during construction now, DEP is going to start requiring confirmation infiltration testing. So after December 8th of this year, in our construction projects and all projects, if you're saying it's supposed to infiltrate, we're not going to be checking that infiltration rate after it's completed in construction before we hand it over to maintenance. So um, the other thing too, in our bioretention, looking at that right type of vegetation, what are we putting out there? Is it easy for us to maintain? Do we mow it? Do we not mow it? Can we get into that? And I have some slides later on, kind of talk about specific examples about that. Um, and then, like I said earlier, infiltration, you probably hear me say this a lot. That's kind of where we see the most is putting infiltration basins where that infiltration was probably right at that limit or level for to meet the DEP requirements for an infiltration basin. So one of the other things I didn't touch on, I have a couple slides on this. A lot of our folks, and I'm going to try to talk through this slide the best I can. Um, this is an example of a stormwater control measure. We kind of tucked it right in here, this roadway. See if my laser pointer works. So right here is a roadway, a ramp coming off here. So we tucked this SCM right in here in the middle. Our maintenance crews, they have no real way to get around there. If you can see here, this top of bank doesn't really give us a whole lot of room to get in there to access that. And this is an infiltration basin, so which requires us to have a low ground pressure type of equipment to get in there. We really don't have an access road. Uh, you can see there's guide rail, kind of goes the whole way around there. So after construction, we had to kind of figure out what do we have to do. So that's just something to kind of keep in mind in the design side. Someone has to get some type of equipment in there to, maintain it, whether it's mowing it, um, cleaning it out, those type of things to try to keep in mind. Equipment access is key when we're looking at that SCM access. Here's another example. This is another example of an SCM where it was kind of tucked in here. Um, and in the original design, it didn't really have a really good access road way to get there. You can see now they have one now that they can kind of get in there. But it gets a little, the biggest thing here, you can also see there's an SCM. It has a fence. There's no gate. The only way we can access this is through private property. So I say this is a road here. That's private property. So for our crews to get there, um, there's a guide rail, a pretty steep bank here. So there's really no way for us to kind of get into this swale with this steep bank. So it's just one of the things that we've had issues with getting into our SCMs is a big thing. And this is another one, and I've taken these from different districts. Um, and a lot has to do with access roads. So this big picture here, all these dots are stormwater control measures. You can see our road here. There's no real easy way to get in there. So for us to kind of get to this one up here in the upper left-hand corner of the screen, it's driving in and around, and we had an old access bed, roadway there, but it's still not easy for our crews to get at. So So I talked about basin issues, not infiltrating. Uh, you can kind of see here, this is an older basin, but it should not have water standing there. Because of that, our maintenance crews actually had to go and replace the soil mixture and install an under drain to prevent that standing water. It was not in that initial design. It's something we're looking at to try to retrofit to meet that, so it's no longer standing water there. Um, so, and that can get costly depending on what type of soil mixture to promote that infiltration. So it's kind of a larger issue us trying to figure out. Just kind of an example too. The picture on the left is before. We had a stormwater control measure, a smaller one. It was kind of tucked in here. You can see it needs some additional maintenance. Luckily, this one did have an access road to it. But some of the things they found here, it wasn't quite performing the way we wanted to. Um, we added some rock in here because we had some erosion issues from the water coming from the road. That wasn't part of that initial design. Um, this was actually a big corrective maintenance. They let a contract out for a contractor to do this because it was a little bit above what our crews could do. So this is kind of an example of good and bad. We had the access road to it, but it was still kind of tight quarters for our to get in there to have equipment go in there and do that corrective maintenance for that. And this just similar picture of that same basin before um the pre and post of that same basin I was talking to prior. Here's another one where we had to do a lot of it was supposed to be a dry detention basin. Um Pictures to the left. Um like I said, you don't have to you can see here it was holding water. We did another large corrective maintenance project. We built it back to per plans. We did install, the contractor did take care of our vegetation there, replaced that filter strip here in the middle. You can see there and installed an under drain to help with that infiltration. I just put this one in. It's not always construction projects. We actually had a project where we had an existing SCM where a sewer contractor went through and plowed through our SCM. So we had to have them rebuild it. So I'd like to point this out, even though they're built and already there, keeping that inspection cycle is important because um, they just didn't think they had to worry about it. So they went through and destroyed our whole SCM. So we made the contractor put it back to the acceptable condition, but it was just a shock thing you don't always think about when you're in SCMs, having to worry about utilities going through existing SCMs. Construction field changes. Some things aren't always caught in design. You can see here the top picture on the left. They had to excavate several feet of rock to install an infiltration basin. Um, so as part of our stormwater committee, we decided to convert it to a wet basin. So this initially was designed for an infiltration basin. We ended up converting it to a wet basin, and it ended up costing us over $100,000, which because it was a wet basin, we had to install a fence on 8 of those, and it wasn't included. The key thing here is, making sure we're doing enough that geotechnical investigation during design to minimize that additional cost when we're out in construction. So that's kind of all my kind of design construction issues. I do want to tie into our SCM maintenance, which our crews out in the field, we have over, I think, 7,000 employees at PennDOT, their maintenance crews. Um, Training them to know what to look for, and how to maintain the SCMs helps us because they have a lot more eyes out there. If they see something wrong, they can bring it to our attention. We can fix that. Um, this is just my plug. Our maintenance training, it's 8 modules. We kind of tell all of our maintenance folks, how to identify SCMs, type of equipment, how to do the routine maintenance activities. And then that knowledge transfer is kind of key. Some of our districts, and these are things I've been briefly talking about with maybe including in some of our design plans, not a permit one, is no mow maps, where to tell them to mow. Um, so we've actually sent this out to our counties to tell them you can mow in these, red areas, there's green areas, that's low ground pressure, or how many times they have to mow per year, or not to mow if we have special vegetation. That was our district's first solution. Their second solution, and I stole this from one of our District 2, I believe, they actually went out and created a stormwater control measure maintenance manual for each county, um, which includes location maps to tell them where they are, where they can drive in and access. Um, don't perform work on, here's an example where they might not be air basins. So just sharing that information that we get from design and construction to our maintenance crews. So that kind of wraps everything up on my end for my presentation.
Thanks, Rich.
Yep.
Let's do the reaction for him. But there is a question in the chat from Beth Dutton. It says, for greater ecosystem benefits, does PennDOT have any SCMs where they have seeded with native pollinator
Yeah.
plants?
Yeah, we do. We have obviously some of our older ones, we don't. Sometimes we seed those. Um, we kind of let that up to the district to pick SCMs where it makes the most sense to have those pollinator plants and those seed mixes in there. Um, so it's not, we don't have like a specific stormwater control measure category that's called like pollinator stormwater control measure, but that's always an option for our designers to include those type of seed mixes where it's appropriate based on the SCM type.
Cool. Are there other questions from the audience? Oh, here comes a question. Okay. Here's another question from Beth. It says, for trash hotspots, is there any preventative maintenance like regular trash patrol to help prevent trash/microplastic generation?
Yeah. So, I mean, trash is another big topic. It doesn't necessarily fall under my area. I mean, our crews are out there always picking litter. We stress folks for the communities for the Adopt a Highway program. Um, you know, it's that trash pickup, and that communication out to the public not to litter. Um, so, I mean, ideally, in an ideal world, no one would throw trash out of their vehicles and we wouldn't have to worry about it, but I don't think that's ever going to happen. So, um, a lot of our counties know where they have a litter and trash, and they'll go out there and send crews out and spend lots of hours and time to make sure that litter's picked up. Um, but we're always looking for different opportunities to reduce the amount of litter we see. So,
Thank you. All right. Any other questions? Remember, we will have a chance to ask questions of both speakers at the end. All right. Once again, thanks, Rich. We can transition to Jim's talk right now, and then you'll have, things occur to you as you're listening to Jim about Rich's talk. Please keep them in mind, type them in the chat as they occur, and we'll have some questions at the end. All right. Thanks, Rich. Jim, please. There you go. Jim, are you speaking?
I am trying to speak. Are you
Okay.
able to
Yeah,
hear?
we can hear you. Now we
Okay.
hear you.
You know that the screen sharing bar covered the button.
I see.
Anyway, I'm sorry about that. Okay, so here we go. Can folks see the slides?
We can see We see the presenter show. So if you go to display settings and reverse it, we'll see them, I think. The top of the screen, there's a little drop down called display settings. A little bit further up. Nope, nope. Go to the left from where you just were. One to the right. One to the right. There's a
Oh.
menu to the right of where your cursor is right now.
Yeah, I'm not. Hold on. I think this the bar is covering the thing up. Um, all right, hold on a minute. Well, I'm seeing. Let me see. Hold on a minute.
Sure. Take your time. Okay, here comes something.
Okay. All right. Are people seeing that now?
We see the slideshow view. We don't see the presenter view yet.
Yeah, okay. All right. Well, you can see the picture anyway. I mean, you can
Yep.
see it, although it
Yes, we
looks
can.
all right. Well, we'll just do that. I have no idea how to fix this. So,
It's okay.
but what I would say here, and this is Jim Pillsbury. I'm from the Westmoreland Conservation District, and I have had a lot of experience with stormwater management practices over the years. And so this talk will be somewhat on experience, somewhat on what we've done here at the Conservation District, somewhat on what we have seen in terms of practices. But the very first thing that everybody needs to think about with stormwater management and maintenance is really what the background of stormwater is. And with land development, and land development in Pennsylvania has always been an issue. Here in Westmoreland County, for example, we are losing population, and we lose about 1,000 people a year in this county, and other counties in the southwestern region lose population as well. But we are always busy building things, and that is what's called sprawl. Sprawl is where you have things that get built and you can't necessarily, in a sense, justify it. So we get all these new houses, yet there are places in our county where there are plenty of abandoned houses. So land development, the water cycle, is where you have to start with maintenance, where you have to start thinking about with your design. We get about 40 inches of rain every year, and that's year after year after year. That's what we get. And so you have to think about that in terms of how am I going to handle this? How am I going to pass this through my site? How am I going to deal with this? And if there is land development that takes place, how am I going to deal with those changes? Evapotranspiration is reduced when you develop land. Infiltration is reduced when you develop land. Runoff is increased. Runoff might be doubled or tripled from a particular site over the course of a year, if you think about the water cycle. And so this extra runoff that comes off of a site leads to um, leads to damage of streams, loss of habitat, things like that. This map here, can folks see this map of the state?
Yes.
Yeah, good. This map shows from a couple of years ago, we had excessive rain. And what we have in southwestern Pennsylvania, the Corps of Engineers has said that in the Ohio River Basin here in southwestern Pennsylvania, they expect over the next 50 years that rainfall will increase and the intensity of rainfall will increase. And so, as you design for maintenance, you have to design for stormwater to handle a larger storm, a faster storm than what has happened previously. And so that's something that we have to think about. Now, this with regard to maintenance here, these bullet points, we'll talk about these. A well-designed system is easier to construct and maintain. And a simple design is easier to construct and maintain. And I've been reviewing plans now for 37 years, and so I've seen a lot of plans that were poorly designed because they were unnecessarily complicated. And you have to step back from your design. You have to look at that design and say, okay, is there a way I can make this simpler? Is there a way that I can make this easier? Because maintenance is not being done by the engineer who designed it. It's being done by someone else. And the person who's doing it may not understand all of the aspects of stormwater management very well. So well-designed system, a simple design. Engineers especially, when I was in college years ago, I had all kinds of classes, but I never had a class on how to run a bulldozer. And so you get an engineer who designs a ditch that's supposed to be 1.327 feet deep. And the guy in the field is building this ditch with a 30-ton machine with a blade 10 feet wide. And so he's not going to get that ditch to be 1.327 feet deep. So I think it's important for designers to go in the field and watch the machinery running, watch the equipment, see how their design is getting built, and then you learn and you say, okay, contractors don't like whatever it is. We're going to design things differently. Then, of course, last bullet point on here is on regulations. We deal a lot with DEP, with the Department of Environmental Protection, stormwater regulations. And we'll talk more about that later, but some of the regulations may pose an obstacle to maintenance. So this section, this slide here, know the hydrologic characteristics of your site. What is the drainage area? What are the soil and slope characteristics? Where does the water go? And one of the slides that Rich showed was busting out rock to build a detention pond. And of course, perhaps someone didn't have access to borings or testings, and they thought, oh, well, put this pond here and it will infiltrate. But if they would have had some tests available to them, they would have had a different situation. This is a house that we looked at. This is not a highway project here. This is about a $350,000 house in a municipality in our county. And earlier this year, we had some very, very heavy rainstorms come through that produced quite a bit of rain in a very short time in a very narrow band. And maybe 4 or 5 inches of rain in just a few hours. But in as I say, a very, very narrow band. This house here was surrounded on 2 sides by several inches, almost a foot of water. If we look at the next picture, we will see the water came up against the foundation of the house. They built the house fairly well. It had excellent foundation drainage. The excellent foundation drainage carried that water, which was several inches deep, down along the foundation. So the water then was introduced under the basement floor. And this was the result. A house that was only 4 years old had well over $100,000 of damage to the house because of this water coming up against the side of the house. Why did the water come up against the side of the house? Well, we went out and looked. We looked at our county's tax map system, and if you have a tax mapping system in your county, make use of it. Ours has contours available. Ours has all sorts of things. Well, the drainage area in that storm of water running to that house was 23 acres of land. So if you got 4 inches of water over 23 acres of land in the period of an hour or two, no wonder the house had this damage. And so the person who designed the house obviously wasn't paying attention to what was going on around the side of the house, and that happens with stormwater management as well. Here's a culvert in the little town of Avonmore. Now, Avonmore is one of those places where the mill has closed and everything's kind of trickling away in a sense. So here you have this cute little culvert, maybe 3 feet square or so, maybe slightly larger. And so this is the downstream end of the culvert. They had several inches of rain. It was the same storm. And that storm dropped several inches of rain, and so the water couldn't go through the culvert. Culvert was too small. Water came pouring over the top. And once again, whoever designed that culvert, and the thing's probably 100 years old, there's 90 acres of drainage tributary to that culvert. And so really we have to, when we think of maintenance, we've got to look around. You have to stand where you're at and look around. Are there houses? Are there trees? Is there a farm field? Is there a shopping center? What's going on around me? And so that's very, very important. There were 30 houses in Avonmore that had damage, water in the basements of 30 different homes. These are people who do not have much money. They are people who have lived in the house maybe a long, long time, and maybe they're on a pension or fixed income or something. And so the failure to consider what was around led to that. Here's another factor at Avonmore. This is a trash rack that was installed at the upstream end of culverts under the old railroad grade, which has been abandoned, and then it goes under the factory, under the mill, which is also shut down. And so someone put a rebar trash rack there. They welded it all up with these very small openings. Those are about 6-inch openings. And it gets clogged very frequently. The water backs up and then causes some of these problems. So when you're thinking of maintenance, you want to think of, okay, in a flood situation, in a high flow situation, what is going to allow for the best continuation of function? And so this is a trash rack that the state put on a lengthy culvert in the city of Jeanette. And you notice the bars. Notice how those bars are arranged. Here's another trash rack that my wife and I saw when we were in the United Kingdom. Notice how the bars are arranged. And this is why the bars are arranged that way, because you can put a machine at the top of the rack and scrape debris up and off the rack. And so this kind of thing here is quite important. And when you have maintenance being done in an urgent situation, as this is here in this picture from California, it's got to be able to be done easily and quickly. Okay, so and this is where you want to communicate with the equipment operators, communicate with the people who are in charge of the maintenance. And sometimes I think that's probably the weak link in this chain, is that someone doesn't communicate with the person who's doing the maintenance. Now we think about small stormwater management features. Here is in Vandergrift. And we designed this. There's a little parklet there, and we designed a couple of stormwater features there. They had torn down a bunch of buildings, and but this is combined sewer, so we needed to be super duper careful about what we did. And so, notice this little detention pond here. Notice the rock riprap where the pipe comes into it. Notice there's a little riser in the background. This is small. It's easy to maintain. There will be some plants planted there. And this is another one in the same parklet. And notice to try to reduce complications, we used curb cuts here to get the water into that little swale. And so someone can keep this swale maintained with a lawnmower and with a rake. And so it's going to be very easy for the borough crew to maintain that. Now, small stormwater features are really something that DEP is looking at, and they want municipalities, they want developers, they want landowners to do this. Small features replicate the water cycle better. You try to spread that out. Small features will fit in. In an urban area, they provide a little oasis, a green area, but they'll add a level of difficulty. And speaking as somebody who's been to lots of sites over the years, it's far easier to inspect one detention pond than 10 rain gardens. And so you have this battle back and forth. What are you going to do for stormwater management? Now, DEP likes you to think about these three things: rate control, volume control, and water quality. And so Rich had a photo there of all kinds of trash building up in a detention basin, and that is sure a problem. And now we think about microplastics. When plastic trash gets into the system, it breaks down, of course. And so we need to try to trap that. We need to try to capture that. And the words that DEP likes to use: disconnect, distribute, and decentralize. And so that is something that they look at. Now, this is a photo or a shot from the GIS system in one of our large developed townships. And you notice the extensive storm sewer system in this housing plan. Now, storm sewers are great. They carry the water away. They get rid of the water. And so, but here's the problem. Water falls on the roof of a house. It runs down the roof to the gutter, it runs down the gutter to the downspout, goes down the downspout onto the driveway. The water goes on the driveway into the street. It runs down the street into the catch basin. It runs through a pipe, and it never has an opportunity to be interrupted or delayed or stopped in some way. And so that is a problem of some land development, that there is this connection and the water never is disconnected. Here's what happens when you have a stream that the water is not disconnected. This is a flood channel in Greensburg, and you notice we had a couple inches of rain, not even very much, and that's full of water roaring along there. This is the same channel on a different day, and you notice there's no water in it at all. That water is probably a quarter of an inch deep. And so stormwater management really needs to look at this as a goal, and that's why they do the disconnection. But I'll show you something here that is one of those flaws. This was a housing development where the township said, let's have the developer do something to disconnect. So they prevailed on the developer to install, about 32 some rain gardens in people's yards. If you look at the photo in some of the yards, you can see some of these little gray rectangles. And so the developer built little rectangles in people's yards. Now, I won't necessarily call them rain gardens, but they were little rectangles. A whole bunch of them, the developer had never connected the roof drains to them. A whole bunch of them were built on a slope, mimicking the slope in the backyard. In other words, they weren't flat, they were sloped, so they would never hold water. And then a whole bunch of them ended up with children's play sets and garden sheds, and so they never got the opportunity to be used the way they were intended. So then we were forced, and the township were forced, to go back and try to get all of these homeowners to put this back in their yard right. And of course, the first thing that anyone ever does when someone tells them to do something like that is they say, well, I'm going to call my lawyer. So that was not successful. So really, the next step of maintenance, when you're thinking about maintenance, you've got to communicate. You've got to communicate with the owner, with the developer. You've got to communicate with the municipality. Maintenance and communication go hand in hand. These rain gardens in the backyards had never been placed in any kind of an easement, so the municipality did not have the right to go in and tear down anyone's play set or garden shed. Now, this is a project we did in another municipality in a neighborhood that was older, it was existing, and we built 21 rain gardens in people's yards to capture roof water. We communicated with those people. They voluntarily signed up for the rain gardens. The rain gardens were free to them, and we had a grant. And so there was communication all along that path. So it was slightly more successful. Here I'll walk through a rain garden construction. This was in Mount Pleasant Borough. This was a parking lot, municipal parking lot with no stormwater control. Water would run out of the parking lot, down the street. It ran across the street, down a guy's driveway, and into his garage. And this was in town, and this had been happening for many, many years. We had a grant. We excavated out about 6 parking spaces out of the 35 or 40 or so that were in this lot. We dug down. We placed a underdrain. We placed fabric and stone. We placed a soil mix. Now, this mix is a mixture of topsoil, sand, and compost. It was manufactured, not mixed on the site. We graded these rain gardens. We had curb cuts. As you can see, the curb keeps someone from driving into the rain garden. The curb cut allows the water into the rain garden. We planted plants, and there is what that looks like when it's raining. So good design can really be a benefit, and it can lead to much easier maintenance. Here's something else that DEP is pushing, and DEP is pushing the use of flow splitters. Now, if we think about the rain that we receive here, most of our rainstorms are less than an inch of water. And even with climate change, most of our rainstorms still will be the smaller storms. And DEP's regulations require you to treat water quality for the smaller storms, not for the larger storms. And so larger storms are controlled for rate and things like that. But the smaller storm, the 2-year storm, for example, is what they recommend. And so you will need to use what's called a flow splitter. A flow splitter is a manhole or an inlet or something that has a means of diverting the low flows to a water quality treatment device and the higher flows to the rate control practice. So this is something to keep in mind. DEP is going to be looking for this. Here's another detention pond we looked at fairly recently. No maintenance in many years. It had developed a permanent pool. There's about 4 feet of mud in there. This is what the riser looked like after they'd pumped it down. And so maintenance needs to be done on an ongoing basis all the time. You need to maintain a pond every year, if not twice a year, 3 times a year. If you let it go, it becomes a huge problem, as you can see through this situation here. If they would have maintained that steadily all along, it would have been a different story. Here's a bad design of a trash rack. Now, the pond outlet of this pond here was a 15-inch pipe. The orifices on the front of this basin here were there was a slot about 18 inches wide and 6 inches high. There was another hole near the bottom with about a 6-inch hole. So the guy had a bit of walkway grating or something like you'd find in a factory, and he had his employees screw that to the front of the box. Well, that clogged up with blades of grass and leaves, and so the whole thing filled up with water and wouldn't drain out. And so maintenance was affected then by this guy's poor choice of a trash rack. This is a basin I saw in Punxsutawney, PA, and that is the opposite, where they had so many orifices that nothing would ever stay in that basin, especially no water. Now let's look here. This is a PennDOT basin. This is on Interstate 70, PennDOT's design group and their construction. They've completely rebuilt Interstate 70 in Westmoreland County. They've done a great, great job. We're very glad for that. Much safer. But this is a forebay. And if you notice the forebay here, it's made with gabion baskets. The bottom of the forebay is paved with rock. It's next to the access road. Someone can come in and maintain that very, very easily. So, as I say, kudos to PennDOT for that. Here's another illustration of a detention basin and maintenance. Notice the side slopes are gentle enough that it can be mowed. You can mow that embankment. You don't want trees or brush growing on the embankment of a pond. But oftentimes there's a big fence, there's a very steep embankment, no one can get in. The vines grow through the gate on the fence, and then you can't even open the gate. And so this basin here then is an illustration of a basin that's relatively easy to maintain. And you can have trees and plants in a basin, just not so they interfere with the outlet structure and not so that they're on the dam itself. Of course, we have permits, NPDES permits, and we talked a little bit about the requirements for that. And so when you're designing for maintenance, you also have to design to meet NPDES standards. Here's a situation where the soil was poor and it was not recognized at this time the project was built. And so they didn't put enough lime or fertilizer or anything on that soil, and you notice it has not grown very well. And so that ditch, that vegetated ditch at the bottom has not worked very well. And this leads to sediment coming into the basin. Here's the contractor waste area. And once again, they did not establish vegetation. They didn't do that properly. And so they had a ditch. They had the ditch lined, but the water coming off overloaded the ditch because there wasn't very good vegetation, and the ditch began to blow out. So vegetation is so very, very important when you're thinking of maintenance, and you've just got to maintain your vegetation. Lime is the key. A lot of our soils have rather a low pH. Chapter 105, we'll just go into this a little bit because sometimes stormwater intersects with DEP's Chapter 105 regulations. This culvert here was not permitted. Notice the sides are kind of sliding in there. It's just a bunch of junky fill they dumped. And so really you've got to be in the field. Engineers, designers have to be in the field while the construction is taking place. This is a situation here where the homeowner had built a very attractive set of little shrubs and river rock and things like that. We had several inches of rain and everything completely disappeared. You couldn't even tell where it ended up. So maintenance needs to take into account these occasional high flows. Here is another PennDOT project. This was done quite well. This is on 356 in Allegheny Township. And this is, you notice they've got these stream banks stabilized with those coconut logs. They've got an overflow area for the water to spill over during a higher flow. They created a natural floodplain. They planted vegetation later on. And so this will be easy to maintain because it was properly designed. It's not jammed in there like the previous slide where you see there's a fence, there's a steep slope, it's in people's backyards. This one here will be very easy to maintain. Now, in case you're thinking that rock riprap is good, here's a project we did in Ligonier, and we stabilized a stream bank using natural techniques. Now, if you let nature do its work, nature will maintain a project for you. And so you see this situation on the right here. We used root wads, we used deflectors, we used veins, we used natural plantings, and that photo there shows what that stream looks like, and its vegetation that was properly selected for that site is doing the maintenance for you. And so that's something that we have found over the years is you let maintenance let nature do some of your maintenance for you. So that's my slideshow. I'm sorry I couldn't figure out how to get it to show, but anyway, I'm sure that when Dan posts the slides, I will send him the proper slideshow, and he can post the pictures without the stuff around the edges.
Thanks very much, Jim. I barely noticed the stuff around the edges. Thank you for the really nice talk. There is a question to begin with in the chat. It says, naturalizing portions of residential park and institutional properties for turf to meadow shrub/trees seems like a fairly low cost, low maintenance approach to stormwater management. Do you think it's effective enough to encourage widespread implementation? I think people would need to get used to this more natural looking aesthetic, though. This is again from Beth Dutton.
Yeah, this is Jim. Yes, I would agree with what she has said here, and I think, as I said, letting nature do its job is quite important. But you have to communicate, and you have to kind of win people over. Southwestern Pennsylvania here is full of older, retired men who like to mow their grass. And I'm only a few years from becoming that, so I have to speak carefully here. But you get some old guy who cuts his grass half an inch high, and he cuts it right up to the edge of the stream. And then you tell him, "Hey, you should let this grow." And that's a big hurdle to get over.
Yeah. Um, Other questions for Jim? You can unmute and shout them out. You can um, put them in the chat. All right. Or, we can also zoom out and ask both of them questions if people have them. One common theme through both these presentations that sort of is popping out is just this whole litter issue. And so there's the forebays, there's ways to do it. I mean, when in the one question I have about that is in DEP guidance, when they're talking about these splitters, how resilient are they going to be to some of the litter issues? And either Jim or Rich can answer that, or both.
This is Jim, and I can answer a little bit if that's okay.
Sure, great. I love to hear.
One aspect of a flow splitter is that it has a small pipe or a small conveyance to carry a little bit of water to a small BMP or SCM, as the
Right.
case may be. And so, yeah, if you have a 6-inch pipe and you have a large amount of trash, that can clog up. So that speaks to the need of inlet filters, perhaps, or other trash control prior to the water ever getting to the flow splitter, and that is certainly a question. The other thing that I would say about flow splitters is you want to place that somewhere where it can be visually inspected, and inspection is so important on these things. Ideally, a flow splitter would be in a known location where the landscape crew, the owner, whoever says, "That's the flow splitter, I know it's there," they can look into the top of it, look straight down, and see if it needs maintained. And so we rather would see grates on top of manholes rather than a solid lid on a manhole, because if there's a grate, a cast iron grate, you can look down and say, okay, this is working, or okay, this is not. If it's a solid lid, you can't do that. And that's a very simple thing to say, but hey, if somebody can't see that it needs maintenance, it's not going to get maintained. So um we prefer these things to be placed in a structure that has a type M inlet with a grate, or it has cast iron inlet or a beehive or something on it, so that people can physically look in and say, yes, that is working, or no, it is not.
Here's another question from Beth Dutton. I'd also like to remind those of you in the audience who are interested in claiming a professional development hour from this presentation, please put your name in the chat so we can make sure to send that certificate out to you. But Beth has a question for Rich, and she asks, does PennDOT need more people to participate in the Adopt a Highway program to help tackle the litter issues? If so, how can we help PennDOT get more volunteers?
like I said, I think we're always looking for people to adopt our highways. We have 40,000 miles of them, so I think we have plenty of opportunity for that. I think, we partner with other state agencies to kind of have that messaging. We work with different groups, but the best thing to do is if you know there's a small group that wants to do litter pickup once or twice a year or whatever, that just helps us at PennDOT, get that litter picked up. So I don't think I don't think we ever turn people down. And reaching out to that local district office to volunteer for a stretch of highway, um, unless it's already taken, we don't tell people no. So
Thank you. Um, Other questions from the audience? Anything you all would like to know about any of these stormwater control measures? Anything about Rich's information system he's been building, which seems like a really useful tool? Um, I mean, I'll ask this because I'm interested. Once you get it all built, Rich, what's kind of the next step? Where are the first sets of analysis you're gonna? Well, you're probably already doing them, but what are the low hanging fruit that you're gonna
I
try?
yeah. Yeah, I think we look at the different types of SCMs that we have.
Okay,
Um, I mean, we really look at maintenance first, we don't want to put SCMs out there that is very labor intensive.
right.
Um, the other thing is looking at that life cycle cost. Like I said, we're getting into some of our SCMs that have been out there, we're going on 15 years now. So looking at those, I mean, I know they're designed under different criteria, but seeing if do SCMs really deteriorate because it's a living type of asset, right? A lot of it has to do with vegetation. Um, so trying to figure that out. So like looking at that whole asset management approach of, but these are assets that the department owns and we have to operate and maintain. So what's the best way we can ensure we're doing that maintenance to extend that life and provide that water quality benefit, to our local streams, right? So does that water quality ever drop off after so many years, or is it we said it was going to remove this much of, sediment or whatever? Is it still doing that 10 or 15 years later? So, I don't have all that data in my database. I'd probably
Right.
more research, but we do have that conditions and looking at that, there's things out there in our inspections and photos and stuff like that. So, um, yeah.
Great. John Burgess has a question for Jim. Says, as you have done your basin retrofits, Jim, have you used those projects as an opportunity to revise or reset maintenance operations at those sites?
Yes, we have. And you remember I showed the picture of the very attractive uh, detention pond with all the grass and the trees and all that, and that was at a property which was a municipally owned property. They had built that detention pond many, many years ago. It had, believe it or not, it had a 10-foot high chain link fence all around it. And the chain link fence had those little vinyl slats in it, so you couldn't even see through it. And so they had to cut the fence to get in because vegetation had grown so through it. But once we tore the fence out, changed the riser and the barrel pipe, we did all that work in that pond. Um, it was a reset, and the maintenance people, in fact, really had never looked inside the fence for 20, 30 years. Now they can because there's no fence, because there really was no need for a fence because it wasn't dangerous. A fence is really if there's something dangerous. And so the side slopes of that pond, we regraded them to be about a 3-to-1. The pond is not very deep, and it has yes, it was a maintenance reset, but on the other hand, the maintenance crew was really glad to see what we did. So yes, that's true.
Thank you. Um, I'll ask one more question, and if there aren't any more questions from the audience, we can say goodbye. But one last question to Rich. So when you're looking at all of your SCMs through time, are you detecting a change in capacity? Are we keeping up with sort of the kinds of changes in precipitation patterns that Jim talked about at the beginning of his talks in terms of the PennDOT SCMs?
Um, I think a lot of our SCMs, I mean, we build them to meet regulatory requirements, right? I mean,
Right,
sometimes we build them in addition to, for flood control. Not normally. We're basically a lot of times our stormwater control measures meet those water quality. But we do see some flood, some of our older ones that may have not been designed for that storm. Sometimes it's like Jim was saying earlier, we designed it and then other land development kind of built in around us, so that land use has changed. Not necessarily the roadway, but what was once a big field is now, and they're supposed to, build their own stormwater control measures, but that land use has still changed, right? So sometimes we might see effects of that. I don't have like hard quantitative numbers, to say,
right.
you know, that it's changed based on, the amount of rain we've been getting. Um, but like some of those storms we get, those microburst type storms, they're what, like 500-year storms. Like we're not designing stormwater control measures for the 500-year storm.
Right,
Like
right.
it would just cost us too much to
I
do
know.
that. So, but I think it's important to look at though, um, if you have very critical infrastructure around there or assets, or I tell people like if there's a hospital and it's only one road in or out, maybe not design it just for that regulatory requirement. So, but that's a one-off thing, right? Like you got
Right,
to know your area and the importance of having for us that access for that roadway, right? Like we don't want it to flood, so maybe we have to do additional things to make sure it doesn't, or you know, um, reevaluating older basins and retrofitting them so they can, take on some additional volumes or additional water quality credit. But um, it's that cost balance though for us, right? Like we look at the department, we have so much funds and what's that benefit to the community versus us retrofitting and doing stuff like that or building a basin that's in design oversized. So
makes sense. All right. I haven't seen any questions popping up in the chat, and it's getting close. It's about 1:14. So I'd like to ask everyone who's been able to stick around for these, for Jim and Rich, to thank them one more time. Thanks to you both. I learned a lot, as always, hearing from the both of you. And we hope to see many of you in late October, early November at the next Lunch and Learn, and then also again in December at the symposium. Thanks much and have a great afternoon.